Hello everyone, this is Neha, and in today's video we are going to study that how we can convert a hexadecimal number into octal, and along with that how we can convert a floating point hexadecimal number into octal number. Basically here we are going to learn the short method of its conversion, because in the last video we have studied how we can convert a hexadecimal number into octal and it's vice versa. But there we have studied a tabular method that is very much effective if you are going to sit in the college exam, or maybe say if you are going to write any subjective exam. But if you are preparing for any competitive exam, then there you don't have that much time that you will sit and make all the tables and perform all the calculations and then perform the conversion. So for that, this particular class is very much important, because here we are going to learn a short method that is very easy and effective in converting any hexadecimal number into octal, may that be the floating point or the simple one. For that, what you have to do is you have to remember just this one rule, and it will be applicable at several other places also in your number conversions. So let us understand that what this rule says. For this, what you have to do is you have to learn the powers of 2 starting from 0 and so on. Means most of the time the very small powers are required. You don't have to go further this. Most of the problems will be solved up to like 2 to the power 5, 6 and so. And it is very easy. Now we will see the method of learning this. See, 2 to the power 0 is 1, 2 to the power 1 is 2, 2 to the power 2 means 2 into 2, that is 4. 2 to the power 3 means 2 into 2 into 2, that is 8. So how you can form this table without remembering these calculations of 2? That is simple. Just remember that you have to start with 1. Okay, write 1 and now keep multiplying this number by 2, and doing so you will be getting the subsequent next numbers. See how I have written 1 here. Now 1 into 2 is 2. Now the resultant is 2, and now you have to multiply this resultant with 2 to get the next value. Now 2 into 2 will give you 4. Now 4 into 2 will give you 8. 8 into 2 will give you 16. 16 into 2 will give you 32, 64, 128, 256, 512 and 1024, and likewise if it is required in any question. So I hope this table is very much clear to all of you. What you have to do is just remember these values, the lower values 1, 2, 4, 8, 16, and it will make the conversion very much easy. Now we will see that how it makes the conversion easy and very short in very small period of time. So we will be solving 2 to 3 problems, and in each problem you will be seeing a different concept, so that you can solve any problem that appears in your exam, and that too in very short period of time. So see, first problem. The question says you have to convert a number 36, and that is a hexadecimal number, and you have to convert this number into a octal number. So now what we will do, whenever you are given a hexadecimal number, then for each digit present in that hexadecimal number, firstly separate their digits, and for each digit present in that hexadecimal number, write its equivalent 4-bit binary number. Now a question may come in your mind that why we are writing its binary number? Because since we are asked to convert into an octal number. For this you have to see the last video. As I have told you in that video, there is no direct possible way of converting hexadecimal number into octal. For that we have to follow an intermediate path where we have to convert the hexadecimal number into an intermediate number, that is binary number, and from that binary number we will be converting that into a octal number. So what I was saying is, for each digit present in the hexadecimal number, write its equivalent 4-bit binary number. For hexadecimal number we have to write 4-bit binary number, and for the octal number, you have to write the 3-bit binary number. I hope this concept is clear to you. Now see that how you will write this binary number without using the table. This is the most important step in this conversion. See, just make 4 places for writing the binary number of 3. Now see this table. Start from this right hand side, and the least significant bit. We all know that here we are having the least significant bit, and on this side we are having the most significant bit. Now start from the smallest values and see which values will sum up or contribute to form the value 3, and that should be the minimum possible values. Now see, if I add 2 and 1, will it be giving me 3? And what is required? Yes, I need 3. So what I will be doing is write 1 on those places which contribute in adding or in making the sum 3, and write 0 on the rest of the places. So since I have made 4 places, and only since these 2 values are required in making the sum 3, and the rest 2 I will be writing 0. Similarly for 6, which values will add up to give 6? See, 4, 5, 6. So only these 2 are required. So at the place of 8 and 1 I will be writing 0. Now at the bottom you can write this rule 1, 2, 4, 8, so that you can cross verify whether you have written this right or wrong. Because if you just make a single mistake, if you write 1 in place of 0 and 0 in place of 1, then that can completely change your answer. So be very particular and be very careful while writing this. So now let us check how the values which are written at the bottom of 0, just neglect, that is of no use, and check for the values where we are having 1. See, 1 we are having here and it is giving us 2, and 1 is here and it is giving you 4, 5, 6. So it is giving us 6. So this means we have written correct. And it is giving us 1 and it is giving us 2, rest all are 0. So 2 plus 1 is 3. So means we have written the binary number correct. Now just recollect all these value in the same sequence that we have acquired from this rule. Write 0, 0, 1, 1, 0, 1, 1, 0, and write them in the same sequence. 0, 0, 1, 1, 0, 1, 1, 0. Now what you have to do is, since we are asked to convert this number into octal, so what we will do, after acquiring this number, you have to start making a pair of 3, and that too from the right side or from the least significant bit. So I will start making the pairs. One pair will be this, second will be this, and third will be this. There is one bit less in the third pair, so we need to stuff the bits. Since there is no 1 in this, so it won't make any effect on the answer. But if it was having any one of these as 1, so that would change the answer. Okay, so now you will write again 1, 2 and 4 at the bottom of these. 1, 2, 4 means we have to write this formula again. Now see the numbers where we are having 1 and add up them, and then you will be getting the answer. See, here we are having 0, so that is not going to affect the answer. Here we are having 1, so see its bottom is 2, so 2 plus, see the next digit, it's 1, and the bottom is 4. So 4 plus 2 will be giving you 6. So it will give you the 1 digit of your required octal number. Now see the next pair. Again we are having same 2 and 4. So it will be giving you 6, and the rest is 0. So it won't affect the answer. So the answer for this particular question that says converting this hexadecimal number into octal is 66 with base 8. So I hope this is completely clear to you. Still, if you have any doubt, any confusion, then please feel free to write it in the comment section. And now we will be seeing a different problem that is quite similar to this, but there is a small change. Here in question number 2, you are asked to convert a hexadecimal number, that is A, B, C, into a octal number. The method is quite similar to the one that we have done above, but here is a difference. See, I have told you that hexadecimal number ranges from 0 to 16, where 0 to 9 are same, and from 10 onwards they are counted from A to F. So see here what you are given A, B, C. So A means 10, B means 11, and C means 12. First of all, if you are given these alphabets in your questions, then you have to write their equivalent decimal numbers, and after that you have to write its binary number. This is the major difference in the above question and this. And it is not the case that either you will be given numbers from 0 to 9 only and from A to F only. It can be a mixture of both, that we are going to see in the next question. But for the time being, just see this. Now we know that 10 is there, 11 is there, and 12 is there. These are the 3 digits of this hexadecimal number that we need to convert. Now for each digit in this hexadecimal number, we will write their binary equivalents using the above rule that we have studied. So taking one by one, now 10 is there. Now see from this side which of the numbers will add up to give 10. So it is, and that should be a 4-bit number. Now see, 8 and 2 is 10. So we will write 1 and 1 at this place and 0 and 0 at this place. So see, 1 0 1 0. Likewise, okay. Now see, B means 11. So 8 and 2 will give you 10 plus 1 will give you 11. So write 1 here, 0 here, and 1 at both these places. So it will be 1 0 1 and 1. Now see 12. Now from this side, see, 8 and 4 will sum up to give you 12, and at the rest of these two places write 0 and 0. So it will be giving you 1 1 0 and 0. So these will be required 3 4-bit binary numbers for this A, B, and C. Now to verify these, write 1 2 4 and 8 quickly under these numbers, and see, this is 0, this is 0, so neglected. This is 1, this is 1, so we will add these 8 and 4. 8 and 4 will give you 12, and here see 8 9 10 and 11. So it is giving you 11. Okay, fine, right? And here is 1 and here is 1, so 8 and 2 is giving you 10. So it means we have written the correct binary numbers. Now write them in the same sequence here, and as we know that we have to convert it in the octal number, so here we will do the pairing of 3 starting from the right hand side or the least significant bit. Now make the pair of 3 3, so it is giving you complete 4 pairs. And now write 1 2 and 4 at the bottom of these number, and for the values where there is 1, just sum up the values. So it is 0 neglected, 0 neglected, 1. 1 is at the place of 4, so it will be giving you 4. The next is 1 2 4, so 4 5 6 7, it will be giving you 7. The next is 1 2 4, 1 is at the place of only 2, so it will be giving you 2. The next is 1 2 and 4, sum of the values where there is 1. 4 plus 1 is 5. So the required octal number for this hexadecimal number, that is A, B, and C, is 5274. So I hope the concept is clear to you. In the next question, what we are going to see, the rest method is same, the rule is also same, but there is a small difference. Here, instead of having only the integer part in the question, along with that we are having a fractional part, but the method will remain same. A small difference will be there that you have to remember, and that I am going to tell you what is that. So see, in question number 3 you are given 1b.3, which is a hexadecimal number, and you have to convert it into a octal number. So for that, what you have to do, just consider integer part first, forget about the fractional part, and in the second step we will see the fractional part and we will forget about the integer part. So let's say we are taking the integer part first. In the integer part we are having 2 digits. One is 1 and the other one is B. So as I have told you in the above question that the alphabet you have to convert it into the decimal number. Now B is equivalent to 11 in hexadecimal. This you need to know to solve this question. And 1 is 1. Now see what places we need to sum the digit to 1. So see, first one is 1. We will only need this place, means 1 will be at this place only, and the rest 3 will be 0. 0, 0, 0, 1 will be the 4-bit binary number for 1. So I have written here 0, 0, 0 and 1. Now B is 11. Now see, 8 plus 2 plus 1 will be giving you 11. So 1, 0, 1, 1. Now I have written here 1, 0, 1, 1. Now you have to recollect these both and write them in the same sequence. So, and afterwards you have to start making a pair of 3, 3 from the right hand side. So doing this you will be getting 1 to 4, 1 to 4, write these at the bottom. Now see, 1 plus 2, that is 3, and here also 1 plus 2, because at the place of 4 in both this pair there is 0, so it will not contribute in this sum, so it will be giving you 33. So the octal equivalent of this hexadecimal number only for its integer part is 33. By now we have not considered the fractional part. So for only the integer part, the octal equivalent is 33. So now keep this aside and come on to the fractional part. Here there is one very important thing that you have to remember, otherwise you will run out of error or you will find out the wrong answer. See, now take 3. Now write its binary equivalent. Till now the steps will be the same. Now we need to see that 1 plus 2 will give you 3. So we will write 1, 1, 0 and 0. So here I have written 0, 0, 1, 1. Now the difference is, in the integer part we were making the pairing from least significant bit moving towards the most significant bit. Means we were making the pairing from the right hand side and moving on to the left hand side. But here in the fractional part you have to start making pairing from the most significant bit moving towards the least significant bit, or in other words you can say you have to make pairing starting from the left hand side and moving towards the right hand side. So see, 0, 0, 1 will be the first pair, and in the second pair we only have 1, so we will stuff 2 zeros like this, and then you have to write 1 to 4, 1 to 4 as per our rule. Now see, below 1 there is only 1, so it will be giving you 1, and here below 1 there is only 4, rest 2 are 0, so it will be giving you 4, forming the number 1, 4, that is the fractional part of this hexadecimal number. So combining this integer part and fractional part with base 8 will be giving us 33.14 to the base 8, that is the octal number for this hexadecimal number, that is 1B.3. So this was all for today. So in today's class we studied two very important things, that is the conversion of hexadecimal to octal number and the conversion of floating point hexadecimal to octal, and that too in a very short and easy method we have done. We have studied tabular method earlier, but here we have studied it using this rule, that is also known as 1248 or 8421 rule. But the main thing is that you should know what the method is and how it actually works. So this was all for today. Thanks a lot for watching, and if you like the content and wish to see such videos in the future, then please like my channel. That really helps me in motivating me for making the new videos. Share it with your friends, and please do subscribe to my channel. Thanks a lot.